Okay, so as request, RFC 2549, IP over avian carriers with quality of service. So this one adds on upon 1149, which I read in the last video on this. So this memo defines an experimental protocol for the internet community. It does not specify an internet standard of any kind. Discussion and suggestions for improvement are requested. Distribution of this memo is unlimited. This memo amends RFC 1149, a standard for the transmission of IP datagrams on avian carriers, with quality of service information. This is an experimental, not recommended standard. The following quality of service levels are available. Concord First, Business, and Coach. Concord Class offers expedited data delivery. One major benefit to using avian carriers is that this is the only networking technology that earns frequent flyer miles. Plus, the Concord and First classes of service earn 50% bonus miles per packet. Ostriches are an alternate carrier that have much greater bulk transfer capability, but provide slower delivery, and require the use of bridges between domains. The service level is indicated on a per-carrier basis by barcode markings on the wing. One implementation strategy is for a barcode reader to scan each carrier as it enters the router, and then enqueue it in the proper queue, gated to prevent exit until the proper time the carriers may sleep while enqueued. So this provides housing and some sort of tracking between hubs to know where your data packet is at the time. It's kind of like, package tracking for any shipment provider like UPS, USPS, and so on. You're able to track where your packet is at along the way and get a route of what hubs it's going through. For secure networks, carriers may have classes prime or choice. Prime carriers are self-keying when using public key encryption. Some distributors have been known to falsely classify choice carriers as prime. Packets may be marked for deletion using red paint while enqueued. Weighted fair queuing may be implemented using scales as shown. So you can weight your stuff. Let's see. So yeah, you can weight it such and then split out. Carriers in the queue too long may leave log entries as shown on the scale. So this just means that they have been there long enough to where they can leave a log that they have been there, and that so you've got kind of two sets. You've got the hub that they are enqueued in, the basically logs that they've been there, and then they leave their own log on top of it if they've been there for too long. The following is a plot of traffic shaping from cooperative host sites. So a plot of traffic shaping shows carriers in flight, so you get from point A over to point B, and these are your different coop hubs. They are able to rest in while they are being enqueued to the next place that they are being routed to, so that your packet, so each hub will basically route out like the next hub that it needs to go to in order to deliver that packet. Avian carriers normally bypass bridges and tunnels, but will seek out wormhole tunnels. When carrying web traffic, the carriers may digest the spiders, leaving behind a more compact representation. The carriers may be confused by mirrors. So mirrors can cause interruption in delay in traffic, is all that means. Round-robin queuing is not recommended. Robins make for well-tuned networks, but do not support the necessary auto-homing feature. So obviously, you've got to send it over the right medium, and Robins just don't make a good medium for that. A BOF was held at the last IETF, but only avian carriers were allowed entry, so we don't know the results other than we're sure they think MPLS is great. Our attempts at attaching labels to the carriers have been met with resistance. It can be difficult to label your carriers, but it helps with tracking, so it's well worth the effort. NATs are not recommended either. As with many protocols, modifying the brain-embedded IP addresses is difficult, plus avian carriers may eat the NATs. Encapsulation may be done with saran wrappers. Unintentional encapsulation in hawks has been known to occur with decapsulation being messy and the packets mangled, which kind of sucks, which means your packet doesn't get delivered. So it may be better to not encapsulate your carrier with saran wrap, but if you take a little strip of saran wrap, you can encapsulate the packet itself upon the carrier, and that will allow for the carrier to escape much easily from such decapsulation by Hawk. Loose source routes are a viable evolutionary alternative, enhanced standards-based MS Windows compliant technology, but strict source routes must not be used as they are a choke point. The ITU has offered the IETF formal alignment with its corresponding technology, penguins that won't fly. So penguins could be used in Arctic environments as carriers in order to provide data transfer to different locations within Arctic environments. Multicasting is supported but requires the implementation of a clone device. Carriers may be lost if they are based on a tree as it is being pruned. The carriers propagate via an inheritance tree. The carriers have an average TTL of 15 years, so their use in expanding ring searches is limited. So this just means that we have to continue to propagate the carriers over time so that you have more carriers to provide continued service, is all that is. Additional quality of service discussion can be found in Michelin's Guide, MIB, and Management Issues. Let's see. AV Carrier 2 object type, sequence of DNA, status living, definition of an avian carrier, life year. Okay, yep. Syntax, set of cells not accessible, obsolete, definition of avian carrier, object type, gauge, read only, current, pulse rate of carrier as measured in neck, frequent sampling is disruptive to operations. If you're constantly sampling your carriers, then yeah, you can slow down your operation. The carriers will not line up in lexicographic order, but will naturally order in a large V shape. Bulk retrieval is possible using the power getNet operator. So you can... provide man-in-the-middle attacks can happen, and your packets can be abducted. But again, it requires the getNet operator to be in. Otherwise, your other... you'd still probably use a net, but you get your get firearm, or by firing arm. But yeah. In this document, several words are used to signify the requirements of the specification. These words are often capitalized: must not, should, and may. There are privacy issues with stool pigeons. Agoraphobic carriers are very insecure in operation. There is ongoing litigation about which is the prior art, carrier or egg. So obviously very, very important considerations to make when it comes to your avian carriers and quality of service. Do not constantly test things. If they are NQ'd, then maybe you can get away with measuring certain things to figure out where they're at in the TTL. But yeah, you're kind of lost if you're trying to do it mid-flight. So finally, RFC 6214, adaptation of 1149 for IPv6. This document specifies the method of transmission of IPv6 datagrams over the same method as specified in the IPv4 datagrams in RFC 1149. This document is not an Internet Standards Track specification. It is published for informational purposes. This is a contribution to the RFC series independently of any other RFC stream. The RFC editor has chosen to publish this document at its discretion and makes no statement about its value. For implementation or deployment, documents approved for publication by the RFC editor are not a candidate for any level of Internet standard. Information about the current status of this document and the errata and how to provide feedback on it may be obtained at this one. Let's see, copyright notice. Okay, so let's see, introduction. As shown by RFC 6036, many service providers are actively planning to deploy IPv6 to alleviate the imminent shortage of IPv4 addresses. This will affect all service providers who have implemented RFC 1149. It is therefore necessary, indeed urgent, to specify a method of transmitting IPv6 datagrams, RFC 2460, over the RFC 1149 medium rather than obliging those service providers to migrate to a different medium. This document offers such a specification. Keywords must not, required, shall not, should not, recommended, may, and optional in this document are not interpreted as described in RFC 2119. Unless otherwise stated, the provisions of RFC 1149 and RFC 2460 apply throughout. As noted in RFC 1149, the MTU is variable and generally increases with increased carrier age. Since the minimum link MTU allowed by RFC 2460 is 1280 octets, this means that the older carriers must be used for IPv6. RFC 1149 does not provide exact conversion factors between age and milligrams, or between milligrams and octets. These conversion factors are implementation dependent, but as an illustrative example, we assume that the 256 milligram MTU suggested in RFC 1149 corresponds to an MTU of 576 octets. In that case, the typical MTU for the present specification will be at least 256 times 1280 divided by 576, which is approximately 569 milligrams. Again, as an illustrative example, this is likely to require a carrier age of at least 365 days. Furthermore, the MTU issues are nonlinear with carrier age. That is, a young carrier can only carry small payloads, an adult carrier can carry jumbograms, and an elderly carrier can again carry only smaller payloads. There is also an effect on transmit time depending on carrier age, affecting bandwidth, delay, product, and hence the performance of TCP. So I can relate to this in that, much like in avian carriers, laying fowl have much of the same curve, where as they are younger, the payloads that they provide are smaller early on, and then they get larger as they get older, and then the payloads, it more is the payload amount kind of tapers off. So you get the payloads becoming smaller early on in life, but they do provide those payloads more frequently, but the payloads will grow. And the payloads, as the fowl gets older, will kind of start to taper out, and you'll have more time between payloads provided based on age as that age increases. So in this case, it's more of like your payload, the carryable payloads get smaller again, and along with it taking the delay being longer, much like payloads from laying fowl can be. So you get smaller and it takes longer. RFC 1149 does not specify the use of any link layer tags, such as an ether type or worse, an ISO link layer or snap header. Indeed, header snaps are known to worsen the quality of service provided by RFC 1149 carriers. In the interest of efficiency and to avoid excessive energy consumption while packets are in flight through the network, no such link layer tag is required for the IPv6 packets either. The frame format is therefore a pure IPv6 packet as defined in RFC 2460, and encoded and decoded as defined in RFC 1149. One important consequence of this is that in a dual stack deployment, RFC 4213, the receiver must inspect the IP protocol version number in the first 4 bits of every packet as the only means to demultiplex a mixture of IPv4 and IPv6 packets. So it does take a bit longer to sift through that, that's all. The lack of any form of link layer protocol means that link local addresses cannot be formed, as there's no way to address anything except the other end of the link. Similar, there is no method to map an IPv6 unicast address to a link layer address, since there's no link layer address in the first place. IPv6 neighbor discovery, RFC 4861, is therefore impossible. Implementations should not even try to use stateless address auto configuration. This recommendation is because this mechanism requires a stable interface identifier formed in a way compatible with RFC 4291. Unfortunately, the transmission elements specified by RFC 1149 are not generally stable enough for this and may become highly unstable in the presence of a crosswind. In most deployments, either the endpoints of the link remain unnumbered or a 127 prefix and static addresses may be assigned. So you've got a couple different things. You can't unicast, multicast, or things like that, much like in IPv4 that easily. And expecting a stateless auto-configuration is just not there. You have to be stateful in your addressing. and the direction that things are going in. RFC 1149 does not specify multicast address mapping. It has been reported that attempts to implement IPv4 multicast delivery have resulted in excessive noise in transmission elements, with subsequent drops of packet digests. At the present time, an IPv6 multicast mapping has not been specified to avoid such problems. Again, the multicast gets very, very noisy at the start, but anyway. RFC 2549 is also applicable in the IPv6 case. However, the author of RFC 2549 did not take account of the availability of the differentiated services model. IPv6 packets carrying a non-default differentiated services code point value in their traffic class field must be specially encoded using green or blue ink such that the DSCP is externally visible. Note that red ink must not be used to avoid confusion with the usage of red paint specified in RFC 2549. To note again that these packets are to be deleted. RFC 2549 did not consider the impact on quality of service of different types of carriers. There's a broad range. Some are very fast but can only carry small payloads and transit short distances. Others are slower but carry large payloads and transit very large distances. It may be appropriate to select the individual carrier for a packet on the basis of its DSCP value. Indeed, different carriers will implement different per-hop behaviors according to RFC 2474. Routing carriers to the territory of similar carriers without peering agreements will sometimes cause abrupt route changes, looping packets and out-of-order delivery. Similarly, routing carriers through the territory of predatory carriers may potentially cause severe packet loss. Very, very severe. It is strongly recommended that these factors be considered in the routing algorithm used to create carrier routing tables. Implementers should consider policy-based routing to ensure reliable packet delivery by routing around areas where territorial and predatory carriers are prevalent. So again, you've got to be careful of your territory and be aware of the hiccups along the way. There's evidence that some carriers have a propensity to eat other carriers and then carry the eaten payloads. Perhaps this provides a new way to tunnel an IPv4 packet in an IPv6 payload, or vice versa. However, the decapsulation mechanism is unclear at the time of this writing. So it also means that you run the risk of having some packets delivered to the wrong endpoint. So you end up having to resend those packets or either rerouting those packets and making sure that they get to their intended destination. Multi-homing considerations. Some types of carriers are notoriously good at homing. Surprisingly, this property is not mentioned in RFC 1149. Unfortunately, they prove to have no talent for multi-homing, and in fact enter a routing loop whenever multi-homing is attempted. This appears to be a fundamental restriction on the topologies in which RFC 1149 and the present specification can be deployed. So you're basically stuck with point-to-point communications with this standard, and you can't quite just hit multiple points. You need multiple carriers in order to provide service to multiple points to deliver your packets. In some locations, such as New Zealand, a significant portion of carriers are only able to execute short hops, and only at times when the background level of photon emissions is extremely low. This will impact the availability and throughput of the solution in such locations. So, daytime delivery may be minimal. Security considerations of RFC 1149 apply. In addition, recent experience suggests that the transmission elements are exposed to many different forms of denial of service attacks, especially when perching. Also, the absence of link layer identifiers referred to above, combined with the lack of checksums in the IPv6 header, basically means that the transmission element could be mistaken for any other, with no means of detecting the substitution at the network layer. The use of an upper layer security mechanism of some kind seems like a really good idea. There's a known risk of infection by the so-called H5N1 virus. Appropriate detection and quarantine measures must be available. Well, you've also got to have backup measures just in case you have to provide recovery from such viruses. And along with the various forms of denial of service, particularly in the case of perching, you have to provide a way to protect carriers from metal projectiles that would deny the service of said packet. This document requests no actions by IANA. However, registry cleanup may be necessary after interoperability testing, especially if multicast has been attempted. Some of that may be, how should I say, you may need to take into account automobile cleaning mechanisms in the case of multicasting, and also other public works mitigations. Steve Deering was kind enough to review this document for conformance with IPv6 requirements. We acknowledge in advance the many errata in this document that will be reported by Alfred Hones. This document was produced using the XML2 RFC tool, RFC 2629. Normative references, informative references, and so on. So yes, you've got to be very careful. And with the planning back in 2011 on IPv6 over Avian Carrier, it is wonderful to know that they are looking ahead at what is coming down the pike. If you liked the content, if you enjoyed it, if you think I deserve it, like, comment, subscribe, leave any criticisms you have or what have you. I appreciate it. Feed that algorithm, like I said, and I will see you guys in the next one.